Hi everyone, welcome to the part 4 review from the Algebra review packet that you guys were working on this weekend. This one is on simplifying radicals, so just like on the last video that I made, I'm going to just go through and solve all of the problems for you and explain what's happening, and hopefully this helps you with any of them that you have some questions on, and hopefully it's a good review for you. So for number 22, we are simplifying this radical, and notice that it says no decimal approximations allowed. Side note, please excuse any clatter in the background. I have dogs playing in my house right now. So for number 22, whenever I see a number like 700, so 100, 200, anything like that, I'm going to say, all right, that's 7 times 100. And the idea with simplifying these radicals is we're looking for perfect squares. So 100 is a perfect square. So I can take 100 and what's happening if I was to really write it out the long way, which I would prefer not to do for most of them, is you can actually separate and find the square root of 7 and then the square root of 100. The square root of 100 is 10. So then we have 3 times 10 times the square root of 7, and we get 30 times the square root of 7. So that's the basics. I'm not going to break it down that much for all of these problems. So for this next one, we've got the square root of 100, or square root of 100 over 49, which we can translate to the square root of 100 over the square root of 49. Both of those are perfect squares. So this just turns into 10 over 7, and that's all for that one. For number 24, if you're paying attention, you might notice that we just simplified 3 square root of 700 in question 22. So we know that that is 30 square root of 7, and then we know that we're adding 2 square root of 7 to it. So the square root of 7 in this case kind of has a property almost like a variable where it makes these like terms. So this turns into 32 square root of 7. Because we had 30 square roots of 7, and then we added 2 square roots of 7 to it, and so we have 32 of them total. Oh, my bad. Okay, for number 25, we need to remember that this is multiplication here, so this is 2 times the square root of 6 times 3 times the square root of 15, and multiplication has the associative properties, so we can rearrange this and say, okay, 2 times 3 times the square root of 6 times the square root of 15. Now, 6 and 15 both are not perfect squares, but we can combine them under one roof. So I'm going to turn that 2 times 3 into 6, and then I've got the square root of 6 times 15. So if I can't find a perfect square here, what I'm going to look for are pairs of factors, and I'll show you what I mean. So square root of 6 times, 6 is 2 times 3. And then 15 is 3 times 5. So now I've got this 3 times 3 here. And if I was to kind of condense that a little more, 3 times 3 is 9. So I can take 3 times 3 and say, okay, well, that's the same as 9. So what's the square root of 9? It's 3. So if you have a pair of numbers under your square root sign, that number can come out. So that those 2 3s, now they're outside of the square root sign, and there's only one of them. And then we have 2 times 5 inside of the square root sign still. All right, now we have 6 times 3, which is 18, and the square root of 2 times 5, which is 10. That is actually fully simplified, so we are done there. And part of the reason that we know it's fully simplified is because this 2 and 5 that are inside the square root sign, we can't break those down and factor those anymore, and we don't have any more pairs under the square root sign, so there's nothing else that can be taken out of there. For number 26, the square root of 12, that's the same thing as 3 times 4, and I'm doing 3 times 4 instead of 2 times 6 because I know that 4 is a perfect square. So if I take the square root of 4, I can take a 2 out, and then I have a 3 left over. 48 has a lot more options, so what I automatically think of when I see 48 is I think of 12 times 4. So we can just do 12 times 4 and see where it goes from there. So 4, like we said, is a perfect square, so I can pull a 2 out, and then I have the square root of 12, but I can still actually factor 12 and maybe get a perfect square out of there. So what is 12? 12 is, just like we said like a couple seconds ago, 12 is 3 times 4. So we're going to have the square root of 3 times 4. We can take the square root of 4 out of there. So we have 2 square root of 3 minus 2 times the 2 that we just took out times the square root of 3. Simplify this, 2 square root of 3 minus 4 square root of 3. And now these are like terms, and this turns into negative 2 square root of 3. Okay, for this one, we are going to want to combine our square roots all under one roof. There's a couple ways that you can do this. You could technically like simplify this before you combined everything. The order in this situation is not actually going to matter. So I'm going to combine everything under one roof, but what I'm not going to do is I'm not going to like multiply the 75 times 3 because I'm trying to break this down into smaller pieces, and so that would be counterintuitive. And I'm also going to make a choice to take the x cubed, and I'm not going to combine those. Because what do I have when I have x cubed times x cubed? I have a pair, just like we had up here with the 3 times 3. So what that means is I'm going to be able to take an x cubed, well, both of the x cubes out of the square root sign, and they turn into, oops. Oh my goodness. They turn into just 1 x cubed, and then we have 75 times 3. Now, the 75 times 3 we can actually do stuff with as well. If you think about it, 75 is 3 times 25, which is super exciting because that gives us 25, which is a perfect square, times 3 times 3. Okay, well, that means that I've got another pair here, so I can take a 3 out, but I can also take the square root of 25 and get a 5. So the 3's come out, the 5 comes out because of the square root of 25, and then we've got the x cubed. Just simplify this to 15x cubed, and you're all done. Okay. For 28, let's get rid of that square root completely, actually, because 50a, we'll leave that up there, 2, and then what's the square root of 25? It's 5. What's the square root of a squared? It's just a. Okay, so this turns into 50a over 10a. My a's cancel out, and then my 50 and 10 actually cancel out, and I'm left with just a 5 for that answer. And that's all for that page. All right, so hopefully that was helpful, and thanks for watching.